Welcome, cool cats and kittens, to Miss Lee's presentation today on functions and relations. So learning goal for today is substitute values into formulas to determine an unknown. So what you're going to do, I want you to take that, I want you to copy this, and I want you to paste it into your weekly check-in. So if you have that on a Word document or if you have that in your books, I want you to do that now. The other thing that I want you to do today is I want you to copy in your success criteria as well into that weekly check-in. So using notation f of x to represent a function and substituting values of x into a function. Finally, what I would like you to do is I would like you to find somewhere, some centralized location. Okay, so this is for your revision, where you're going to include all of these terms and their definition. So this could be in the back of your book. This could be on a separate Word document to your weekly check-in. You could submit it with your weekly check-in if that's what you wish to do. All right, so primarily what we're going to be doing today, we're going to be talking about how we've substituted values into a formula. We've done this so many times before. We know how to do this. We've substituted in values for x to find y. We've had to substitute values into y and rearrange to find x. All we're going to be doing today is we're just going to be, doing it a little bit differently. We're going to be using a slightly different name, a slightly different notation for y, okay? And that different notation is going to be f of x. So we're going to talk about that, okay? So before we do that, what we really need to be looking at is we need to be talking about what a relation actually is, okay? So a relation is really just a set of ordered pairs, x and y, or it could be a line, or it could be like a mapping diagram. So we'll talk about that in a sec. And all that is it's telling us the relationship between x and y. Okay, so there's 4 different kinds of relationships. So I'm going to very briefly talk about them. Okay, we've got a one-to-one relation, one-to-many relation, many-to-one relation, and a many-to-many relation. Now, in my opinion, as a maths teacher, I should probably not have an opinion, but these are dumb, right? This is the dumbest way I've ever heard to refer to anything. Okay, there's really only 2 key things that you need to take out of this, and that is the vertical line test and the horizontal line test. Okay, so one-to-one relation. A one-to-one relation has only one value of x that maps to one value of y. So you can see over here, this is called a mapping diagram. I've got my one value for x. I input that into some sort of machine or function or rule, and I can't see what that rule is at the moment, right? And then that gives me my output value for y. And every one value for x only corresponds with one value for y. So I might do an example of this. So if I had f of x, right, my function of x, which is equal to y, okay? So y is equal to 3x plus 1. Now let's say I wanted to substitute in the value of 0. So if I substituted in 0, so in other words, f of 0, then I'm just substituting in 0 for x, and we know that that's going to be equal to 1. So 0, if I input the value 0, I put it into my machine, and then I get the value 1. And I'm only ever going to get one value from that. Now, easy way to test this, karate chop test. So all you're going to do is you're going to get your points or whatever, or you're going to get your equation, and you're going to plot it on a graph. If it's not plotted on a graph already, you're going to do a karate chop. So what I mean by karate chop, you're going to draw a straight line through the function, vertical straight line through the function. And if you were to do that karate chop at any single point along that line, then you should be able to show that there's only one point which it crosses, right? So I've got all these coordinates put here. If I was to karate chop through any point, we would know that that's a one-to-one relation. Right? If I was to include another point here, so let's say I included that point here, then if I was to do my karate chop now, then you would be able to see that that's no longer a one-to-one relation. Okay? So this is what we actually call a one-to-many relationship. So let's say I do my karate chop, I actually worked out that there's 3 different values for y, okay, that correspond to this one particular x value here. Okay, so this is a one-to-many relation because if I do karate chop test, one value of x has many possible values for y. Okay, The other kinds of relations that we've got to talk about are the many-to-one relations. So with these ones, instead of doing a karate chop test, what we're going to do is a DJ on the decks test. So if you imagine that you're going to spin some decks as a DJ, so you're spinning your decks horizontally, right? And if I was to draw a line through any single point, then we can see that this now crosses, okay, at two different points. So let's do an example. So I have my function of x, which is equal to y, and let's say that that's equal to x squared. Now let's say I wanted to substitute in a value, so let's substitute in -3. So the value of the function at -3, so in other words, the value of y when x is equal to -3 is going to be equal to 9. What other value of x could I substitute in there to also get 9? Well, I could also substitute in +3, couldn't I? Okay, so again, I'm substituting in to find the value of the function when x is equal to 3. So in other words, the value of y when x is equal to 3. And we know that that's going to be equal to 9. So there are many x values that give the same value for y. Okay, and we can see this here in this mapping diagram as well. So you have many points, okay, many points that lead to the same y value. So this is called a many-to-one relation. All right, the last kind is the many-to-many relation. So if you do a karate chop and a DJ on the decks, you can see that this is going to cross, pew, pew. You're going to see that this is going to cross both axes at, both of the lines at the same time. So there are many values that will lead to many values. So an example of this is generally like a circle function or like an oval function or something like that. These ones aren't too common. I shouldn't call it a function because it's not a function. Let's talk about that, okay? So a function is simply a relation that passes the karate chop test. So if I was going to draw a Venn diagram, right? So this beautiful circle, stunning, should be an art teacher, my gosh. If this was a circle that contained all of the different relations, so the one-to-one, one-to-many, many-to-one, many-to-many relations, right, then functions are a special subset of this. And functions are specifically relationships that pass the karate chop test, okay? So I want you to have a go at these, right? I want you to pause the video. I want you to do some karate chop tests, and I want you to tell me if these are going to be function, so in other words, if they pass the karate chop test, or if they're a relation. Alright, so I'm assuming that you paused the video, so let's go through. So this one here, I could cross this at any point and I'm only going to get one value. So this is a one-to-one relation. This is definitely a function, definitely passes the karate chop test. If I was to do the karate chop test with this circle here, that's going to cross at 2 points. Right? This is a many-to-many relation. This is not a function. Sorry, let's do this. So this one is a function. This one is not a function. Now this one here, if we were to do our DJ on the decks test, we could see through our DJ on the decks test that this is crossing at 2 points. But do we care? No, because it's all about the karate chop test, isn't it? So if I do my karate chop, again, at any single point, it's only crossing through once. Therefore, it is a function. Okay, so let's talk about the domain and the range of a function. So we've talked about functions as kind of like a machine, right? So you have your input value. So let's call our input value x. You have your rule or your equation, right? And that will give you an output. So I've got an example over here. I've got my input value of x is 4. I put it into my machine or my function, which is y is equal to 2x plus 3. And then I spit out my value, which is 11. So if you were to imagine a domain, right? The domain of a relation is all of the values of x that I put into my machine, okay? So you might be given a straight line as a graph, like that, right? And it can continue on this way forever and ever and ever, and it can continue on this way forever and ever and ever. So I could actually write that my domain for this particular function is infinite. So the way that I would write that, so my domain for x. Now, I could write this as this goes all the way back, continuing all the way back to negative infinity. So I can write that to negative infinity. And then it goes all the way up to positive infinity. Now keep in mind, you never actually reach infinity, so that's why we only ever do the less than sign. We don't do the less than or equal to infinity. You can't equal infinity. Infinity goes on forever. Now the range is all of the output values. So again, let's take our straight line function. Now for these y values, we can see it's going all the way down, okay, and it's going all the way up. So we can say that the range, or all the possible y values for this one, are again going to go from negative infinity, less than y, less than positive infinity. And all this means is that it's going from negative infinity, not including negative infinity, because we can't ever be equal to it, and then all the way to positive infinity. Again, less than infinity, because we never quite reach it. Okay, so that is the difference between our domain and our range. So basically, domain, it's your x values, range is your y values. Let's do another example of that. So if I had some information here, so state the domain and the range of each relation, then determine whether each relation is a function. Now for a function, remember, we do our karate chop test, whatcha, and we work out if it passes. So if it passes, it only crosses once. If it fails, if it crosses multiple times, it's not going to be a function. All right, so for this one, let's state the domain. So the domain, remember, is just simply going to be all of the x values. Now for this one, they've given us some points, so we can just say x is an element of 100, oh my gosh, 200, 300. Okay? For our range, now the range, remember, is all of the possible y values. And again, this is just a bunch of coordinates, so we can just say that y is an element of all of these values, 50, 100, and 150. Now for this one, what I might actually do, I'm just going to go over here and I'm just going to quickly draw it. So if I say that this is roughly 100, this is roughly 200, and this is roughly 300. And then for my y values, what does it go up to? 150. So let's just do 50, 100, 150, and let's plot those points. So the first one is here. Oops, excuse me. The first one is here. The second one is here. And the third one is here. Okay, so again, if I was to karate chop that, we can see that it only is going to cross once, and so therefore passes the karate chop test, and so therefore number one is indeed a function. Okay, so let's have a look at the second one. So the second one is even easier. So the domain, right? So x is only equal to 3. Okay, or we could say that x is an element of the subset 3, but I mean, I think I'd just prefer to write this because that's the only value there. The range, so our possible values for y here, we've only got a couple, so y is going to be an element of 1 or 5. Okay, so again, what we can do is we can graph that real quick. Let me just write this stuff out. Okay, I don't know if we really need to graph this. I think you can probably get the point now, but if I was to graph this, I have the same value of x here, which is 3. And it's going to go through at 1 and at 5. So if I was to do my karate chop test, clearly this is not going to pass. So this one here is clearly just going to be a relation. Okay, so number 2 is just a relation. All right, let's go through and have a look at these last two. Okay, so this one here, again, it's very similar to this one. We only have one value of y that's corresponding to one value of x. I could probably guess what this relationship is going to be between. Okay, so for this one, again, if we were to look at the domain, we know that x is an element of the subset 1, 2, and 3. We know for the range, all the possible y values, it's going to be 2, 4, and 6. Okay, and I know that this one is going to be a function because all of the possible x values only correspond to one y value. This one here, straight up, like we can see, this one is not going to be a function, right? Because it doesn't pass our vertical line test. All right, so let's jump in the domain. So all the possible x values. So if I look here, this value of x here is going to be equal to 0, and it's only going to go to 10. And it's actually touching those points, 0 and 10. So it's equal to, it's included. So let's write this as 0 less than or equal to, because it's touching, x less than or equal to 10. Okay, and then for our range, we can see, I think that's -2, so it's touching the -2, and then it's touching the +8, so it's going to go from -2 less than or equal to y less than or equal to 8. Okay, and not